Hello all. My name is Vidyanand Kesti. Today we will discuss about the density. One fine night when I am seeing outside the moon and all the clouds are the moving on moon. This was a very fantastic night and suddenly rain started. When rain started in villages we lost the power cutoff. When the power cutoff happened, then I request to my mom and father give me kerosene diya or the lamp so that I can read my book. So tomorrow I can attend the exam by completing the syllabus. My father gave me a lamp or kerosene diya. So that time you get the variety of the different shapes and the size of kerosene diya or the lamp. Just I'll explain what actually meaning of the kerosene lamp. You can see the kerosene lamp is contain the glass chimney and there is a one stem. In that stem, or you can say the hollow pipe, from that the wick is passed, and in the bottom it is the collector or the reservoir of the kerosene. So this glass chimney is helped to protect the flame by wind, and by increasing the flame height we can adjust the knob. By seeing the kerosene lamp, just this is the chimney, by you will see the parts by this is the kerosene chimney, this is the reservoir, and this is the operating equipment. When you operate the operating instrument, if you operate in the clockwise direction, the wick will height of the wick is increases and you will get the bigger flame, and when you are making in an anti-clockwise, automatically the wick will go down and flame will be off. So there is the mechanism, you can remove it and put the kerosene in the bottom or the reservoir. Automatically wick will be suck the kerosene and it gives the flame. From the flame will get the light. But that day when I am start reading, I saw that there's something problem in the kerosene lamp. What's the problem? So if you see that when you are rotating in a clockwise direction, wick height will be increases, but after some days wick will also burn. And to get the more proper flame, we will usually cut the darked part and we will flame on the fresh wick, so the flame will be formed very uniformly and will get the proper light. So what happen if you are cutting a day by day or month by month, the wick height will be reduces, and when it will reduces, it will not reachable to the kerosene. That day it happened to me. So when I see the kerosene lamp, I am not able to get the proper flame, and after some time it off, because the wick will not able to reach the kerosene. Then I request to my father, I need a kerosene or I need something to get the flame so I can read it. Then my father saw the problem and he understood that okay, the wick is not able to reach the kerosene, that reason we are not getting the flame. So then immediately he opened the container or the mechanism, and in the reservoir side he put the water. Then I am surprised how the kerosene will give the flame to me. From that flame I can get the light. But after some seconds, the slowly kerosene is moving up and water is collecting the down. When it move up, then it start reaching to the wick, then I get the light. I am really surprised by this. Oh, my father did the magic. By that I can get the flame, from that I get the light, so I can read the things. Then this was the strange for me, how it happened. Then I slept. Then morning I wake up. When I wake up, then my mom asking the milk from the milkman, and the milkman measure the milk quantity and given to my mom, and mom immediately put an instrument to that. When she put the instrument to that, and she said to him, the milk quality is not good. You added the more water to the milk. I am surprised. Why and how this small instrument can measure the milk quality, either he added water into it or not. Then when I opened that model, then there was the mark in that. So my mom said to me that when when this instrument is called as a lactometer, this instrument when it's moving downward direction, then we will think that he added the more water. If it is pure milk, it should be go up and it float on the milk. If it is going downward direction, the quality of the milk is not good, and he added the water to this. So that reason you can see that the above is the water and below is the milk. And if it is floating on it, then the mark will come somewhere here or here. Then we see and say that milk quality is good. If it is moving downward direction inside the milk, then it reaches to the water level. And this lactometer is containing a small bulb, so that bulb will help to move up and down. So that reason today also we call it as what degree of a coffee. The what degree of a coffee means what degree of your milk quality. So milk quality is measured with the help of lactometer. That day also I am surprised how this instrument can easily measure milk quality. Then how this instrument is measured? This was in my mind. Then I went to one of my professor home, and I see that in the showcase they put one of the glass model. It contained the color liquids. Then I asked to him, what is this? This is say that this is made with a different liquids. If you keep one over the other, automatically they float one over the other. Then you will get different type of the design. Then I asked that, professor, how it float, how the kerosene float on the water? This is strange to me. And how this different type of the liquids are floating one over the other. And who found out this all methodology? Then my professor said that we will go to one of the story in very long back, then we can understand the thing. In the story he started the place called as Syracuse. Syracuse is close to the Rome, and it is on the side of the seashore. The story started at the 2014 and 2012 BC, so around 2014 BC. There was a king called Hiero. He was the king of Syracuse. He was under tension, and he was a lot of the depression also, because the Rome people, they'll come from the seashores and from the root of the sea. They always fight with them, and by that Syracuse was not safe, and Hiero too was really in the trouble, because Syracuse city was very small, Rome was very big, and many times these enemies are start fighting with the Syracuse soldiers. Hiero king think that how to solve this, because he is losing lot of soldier from their side. Then he called for the meeting, then we will go to the war. Then when he called for the meeting, Then he said that we are in the big trouble. Many Rome or our enemies, they are always fighting with me. What to do? And my request is you come with some ideas or something so you can kill the enemies without losing our soldiers. Then one guy stood up and I said that I can do it. He was a very young man. And king is also surprised that how he can do it. And Hiero too told to him that, oh my young man, you can take whatever you want and you can save us. Young man requested to king and he asked a lot of the copper and the bronze metals. And these copper and the bronze metals that day it was used for the household activity, household equipments and the plates and the dishes. And he collected all the copper metals, raw coppers and the by the pots, and he melted and he molded in a proper way. By that he can get the concave shape of the model. And in the concave shape of the models, he made a very highly polished surfaces at the front surface or the inner surface of the concave models. And that concave models he brought it on the seashores and he kept it on the seashore with a particular angle. When sun rays are fall on this, and these all rays are he concentrated on the ship or the boats, so automatically these ships are burned out. And by that he killed many enemies as well as he burnt many ships. And lot of enemies are died without losing a single person from the Syracuse. King was very happy because he won the war. So after the war, he called to that young man, and for that young man, king asked that, who are you? That day he said that young man, my name is Archimedes. So Archimedes saved the lot of people and the life of people in Syracuse, and now he become a very popular person. So about Archimedes, Archimedes was born in Syracuse city at 287. He was the son of an astronomer and mathematician named as Pleiades. Aside from that, very less about his childhood, all these theories is not have the much information. But after this solar rays, he became a very famous person in Syracuse. And because of the solar rays and lot of the equipment found by Archimedes, by that King Hiero won the lot of battles, and now Syracuse city was very safe. By that time, king thought that okay, this is everything. This world is done by God, so we will give a crown to a god as a gift. Then immediately he called a goldsmith and he told to goldsmith that you make a very beautiful crown, and that should be a very good or very beautiful, and whatever how much quantity you want the gold you can take it. By that he measured the quantity of the gold, that same quantity of the gold given to goldsmith to make a very beautiful crown. King was waiting for that time, and that time came to in his meeting, and he got a very beautiful crown from the goldsmith. And King Hiero too gave a gift to goldsmith about by making this very beautiful crown, and king was very happy. So that he called for a meeting, and in the meeting everybody is saying that what the crown is made by the goldsmith is not pure condition. Everybody is saying that crown is not pure. Then that reached to queen, and queen informed to king that what you made a crown and what you want to give to God as a gift, that crown is not made by the pure gold. So if it is not made by the pure gold, then we will not able to give to the God. Then he immediately called a goldsmith and come to the goldsmith, and he came to in front of king, and he asked the same thing to goldsmith. Hey goldsmith, what you are given as a gold crown, this is not made by the pure gold. What the people is saying, is it true or not? Then goldsmith say that, see my lord, you given me as some quantity of gold coins or the gold blocks. You put it in one side, in other side you put it in the gold crown. You see that both are weighing in a same. Then it is surprising to king also, because whatever the gold quantity given to the goldsmith, the same weight is also showing in the balancing equipment. And king is also still in the trouble, he not able to resolve this issue. That reason he called Archimedes. And he told to Archimedes, king told to Archimedes that, hey Archimedes, what I got a beautiful crown from the goldsmith, that was very beautiful, and people are saying that it is not made by the pure gold. If it is not made by the pure gold, then I can't able to give to the God. Then now this problem come to Archimedes. Archimedes start thinking on this about the goldsmith impurities and the gold crown. But the problem is, if it is a regular shape, suppose if you see it's a gold block, if it is a regular shape, I can measure length, breadth and height. By that I can get the value. Then I can easily weigh it, so I get the some kg. The measuring the value is very easy for the regular or the square things. But if you see the crown is a irregular shape. We can't measure the volume of this. We don't measure the like a length, breadth into height. It is totally different. It is not a round. If it is a round, again the leaves are there in this. So how to do that? This was the problem, is thinking daily how to measure the volume of a crown. And in the same day, and in one fine day, he is thinking in the same way, and he sit in the one water tank, and some quantity of the water is spilled out by the tank. Then he understands why the water is spilled out. That he understand, okay, the whatever the weight of my submerged body is equal to the weight of the water displaced. In that way he easily understands that, okay, the whatever I put the object inside the water, then same weight of the water comes out. That what he got the idea. When he got the idea, and he suddenly comes out without any dress, and he saying that Eureka and Eureka. Eureka means I found out. So here easily you can see that by the instrument, just any things you can put in the water, same quantity of the water is displaced. Or you can say that if the metal, if you put the equal weight of the displaced, okay, if you put the metal, the weight of the metal is equal to weight of the displaced fluid. That what he found out. And he come back to his lab, and he start measuring the density of the water. So the density of the water is very important to measure. So that reason he took different models, and he collected the water. Even he put the crown, and he get some quantity of the water. And the king is seeing that, but he not able to understand. Then he say that, king asked to Archimedes, what are you doing? Then Archimedes say that, wait my lord, I am solving the problem. But before that, I am measuring the density. Then what is the density? Then density means how tightly matter is packed together inside an object. Then if it is packed tightly together, then the density is very high. If it is packed lightly, then density is less. So density is equal to, it is a ratio of mass or weight divided by the volume. So this is what he is struggling. And before that, you want to measure the density of water. How we can measure the density of the water? Even you can do it easily. You can put it weighing machine as the empty instrument or a empty measuring instrument, and you measure it. You will get the 11 gram. You put some water at a certain level and you measure that up to what level you pour the water, that is 7.3 ml, and again you weigh it, you will get the 18.3 grams. Now you weigh the weight of the water. So if you are weighing the weight of the water, you should be subtract the weight of the glass or the empty instrument. So that reason I did W2 minus W1. So I got it as 18.3 minus 11 divided by 7.3 is equal to 1 gram per ml or 1000 kg per meter cube. Okay, so by that, if you, for understanding of your purpose, always the mass of 40 ml of water is 40 grams. If you taken the 1 liter of the water is always equal to 1 kg of the water. So that reason the density of the water is close to 1 gram per centimeter cube or is equal to 1000 kg per meter cube. So by that he measured the density of the water, and king asked that you measure the density of the water, then what to do next? Then for understanding him, he say that just he took one small stone and put it into the glass jar or the glass equipment, and automatically water will be raised. Then he showed that whatever the quantity or the mass or the weight of the object you are putting into the water, the same quantity of the water will be rise or it will be spill out. Suppose if you want to measure the density of a key, it is a irregular shape, you can't able to measure with the help of any instrument. Only we can put it into the water, water will be rise certain level. This rise we can measure, that will give the volume, and you can easily measure the mass of the key. Then if you keep the ratio of mass by volume, you will get the density. Suppose you can see that volume of the water rise. Suppose if you are putting the key in the same instrument, volume of the water is rise from 150 to 158. So I kept it as 158 minus 150 is equal to 8 ml. 8 ml is the rise of the water. So 8 divided by 1000 I did it. I convert ml into liter. Then I convert into meter cube divided by the 1000. So I got the volume is 8 e raised to minus 6 meter cube. Then I can easily weigh the weight of the key, that is 100 grams, or can convert into kg, it is 0.1 kg. So density is equal to weight divided by volume is equal to 12,500 kg per meter cube is the density of the key. This is the irregular object. Then he come to his real problem, and he called to the gold and the king, say that now you can easily measure the density of a gold. Density of the gold, if it is a pure gold, then it is mass divided by volume. Mass I can measure, it is a regular shape, that reason I can measure length, breadth into height, I got the volume. So automatically my density is equal to mass by volume. I got the ratio or the density of the gold. This you can say the pure gold is 19.32 gram per cc, or is equal to 19,320 kg per meter cube. But this crown is a irregular shape. You put into the water and he collected the water quantity or the volume, then he weigh it. That ratio you got as 14.2 gram per cc, or 14,220 kg per meter cube is the density of the crown. By this he easily showed that, see the density difference between the gold crown and the pure gold, almost it is different, means total it is different, it is 19,320 but it is 14,220, means it is easily indicate that he added some impurities and he took some gold. But he want to explain to the king, but in that immediately goldsmith entered and said that, Mr. Archimedes, you can see that weight of the crown is equal to weight of the gold coin given to me. I am not added any impurities, I am not removed anything, because the balance will be remain same. To understand this, I need one Excel sheet to demonstrate how he did it. So then we'll move to the Excel sheet. I'll show that how Archimedes explained if the weight will be remain same but your density is different. Okay. By that also the goldsmith is not agree. Goldsmith is always saying that my mass or the weight of the both the gold and the gold crown is same. If suppose I am added some impurities, or if suppose I am removed some gold, then how much of the gold I removed? You just tell me. Then Archimedes is smiling and show that I can prove that. To understand this, we will go to the Excel sheet. Now we will start the method 1 of the weighing the impurities, or the how much impurities added in the crown. First we will measure the diameter of the container where we want to measure this gold or the crown. So I took it as the diameter of the container as 22 centimeter of the model, because if you see the crown, it is 20 centimeter in the diameter. So I took some more bigger than the crown model, and it weighs 1000 grams, almost 1 kg. Then I took as the diameter of the crown D is equal to 22 centimeter, and weight of the crown is 1000 grams, and area of the container is 380,182. So this is the area I measured because I required the volume. So that reason I need the area. Area is equal to pi by 4 d square. So I use that equation here to calculate the area of the container. And I know the density of the pure gold by measuring the volume as length, breadth into height, and I know the mass of the pure gold. So I find out the density of the pure gold is 19.3 grams per centimeter cube. Then as well as I measure the density of the water is 1 gram per centimeter cube. So now what I did, what Archimedes did, he put one gold block or the gold coins in the container. So it will rise of 0.165 centimeter for the pure gold or the gold coins. This much of the rise of the water. Now he removed the gold coins or the gold block. Now he put the crown. When he put the crown, it rise 0.2 centimeter. So I rise the water rise in the container of the crown is 0.2 centimeter. Then I took the difference of this SC minus H1. So I got the difference of the rise is 0.035 centimeter is the difference of the rise. So that we call it as the height. So if I know the height of the water rise and I know the area of the container, so then I can calculate the volume. So volume is difference of the volume is 13 centimeter cube is the difference of the volume. So I know that this is the volume. So I kept it here and I can measure it. So volume is measured here, density is known to me, and what is the mass. So if I calculated this, so if I calculated of the water, then I want to measure the mass. Density is 1 into volume is 13. So it will come around 13 grams. So 13 grams of the impurities he added in the 1000 grams of the gold crown. Okay. Then This is little bit complicated. King not able to understand that, and but king asked the same question to him, that if we go again the PPT, it shows that the weight of the crown is equal to weight of the gold coin. You can explain me very easily that how much of the impurities he added. Then again I'll go back to the crown and use the method 2. Okay, in the method 2 what he did, he put this weighing what a crown and the gold have equal weight, the same equipment he put in the water. When he put in the water, crown weighs 935 and gold coin weighs 948 in the water. Then again also he got the 13 grams of the weight difference. Okay, when he measured, the weight is 935 of the crown, and when he measured the gold coin in the water, the weight is 948 grams. Then the weight difference is 13 grams. Now here also you find out 13 grams of the weight difference is there compared to 1000. So in the 1000 you removed the 13 grams of the pure gold and you added the impurities. By that king was very happy by seeing this, and king gave the punishment to goldsmith. By that Archimedes he solved the very miserable problem the world, and he gave the very important property of the material is density. Density is a unique property of a material. It is changes material to material. So that reason he say that density is how tightly the matters or the molecular are packed in the object. So in that way he say that the density is equal to mass by value. By that understanding this, and we will understand what actually meaning of the mass and weight, because density is equal to mass by volume, but here we measure the instrument and we put but by measuring the instrument that we put it as the weight. Then what actually difference between mass and the weight? Mass is the amount of matter content in an object and how much stuff inside the known value is called as a mass. The amount of matter content in an object or how much of the stuff inside is known inside in the known value is a mass. And mass is constant if we measured anywhere in the universe. Weight is the effect of the gravity pull. You have to consider the effect of the gravity. So that what I say, that mass will be same in the universe, but weight will be changes depending upon your position, because depending upon your gravity force acting on the object. So my weight, if it is something in the 72 kg, so in the different planets it measure the different, because it's a weight, it is not a mass. Mass will be always constant. But in the earth, if you are measuring the density, if you are considering the weight by volume is equal to mass by volume. Mass and weight is almost same in the earth or on the earth. Okay, so one more, the important is the density of the different material is different. Suppose if you see that your volume is same, but what Archimedes say that matter content in a body or how moleculars are tightly packed inside the object is also important. Measurement wise the volume is same, but if you weigh it in a weighing machine, it will be the different because of the molecular or the structures. Because if you take the sponge like a material, it is very lightweight, the volume is same, but the mass is very less. Here also the volume is same, mass is different, but in the iron the volume is same compared to sponge and the metal, but the mass is very high. So that reason if you measured it, it is if you see the weight is different, volume is same, by that your density will also different. Okay, so now we'll go to the one more term is called as bulk density. Bulk density usually used to measure the density of the particle, density of a sand, density of the soil, density of the dust. So in these, the moleculars are not closely packed or tightly attached, and they are separate. Such type of the particles, we have to use the term is called as the bulk density. So bulk density measurement is in the different way. If you say that solid particles, you can see that it is a solid particles, or if you taken into the one container, and if you zoom it look like a packed, but somewhere the voids are there. But in the solid everything is completely packed, but in the perforated or the porous materials or the filter materials, these are not completely packed. So if you see that 100% it is a solid, you can say the weight is 2.66 and volume is 1 centimeter square. Volume will be remain same because length, breadth and to height, but if you see that weight is the different. In this case 50% of the solid and 50% is a pore place, then weight is very less and volume will be remain same. Automatically density will be affected. By seeing the next pictures, the voids are more. When the voids are more, it contains a lower bulk density, and also if it is lower bulk density means it is in the lighter weight. But if you see in the other picture, it is tightly packed compared to the previous one, so less pore space or less voids, so by that the bulk density is high and it is shows the higher weight. To measuring the bulk density is the different way. You can take one open both the side or the closed model, you can take it, and you can measure the weight of the empty pipe or empty container, and just put the sand on this, don't tap much, and just remove the excessive sand particles on the top of the surface, and it look like this. So it is loosely packed, and by this you can easily measure the density of bulk density of the model, and by measuring the dimensions of this. To understanding more, again we will go to the Excel sheet. So we will do the small experiment on the bulk density. Now we will measure the bulk density. So in the bulk density, as already told, that we have to fill the sand particle or the dust particle in the pipe. So we'll measure the pipe diameter as 0.07 and the h is 0.01. Up to this much height we put the sand particle. So we will measure the pipe volume. So to measure the pipe volume, first we will measure the pipe radius and the pipe height. By that we calculated the volume. The volume is nothing but area into height. So I converted 3 pi by 4 r square into height. I got volume of the pipe. So now we will measure the weight of the wet sand. So this is maybe the wet. So we'll measure it in the weight in the weighing machine, the wet sand, and we'll dry it in the sunrise or the within oven or something instrument, and we dry it. After the dry, we'll measure the weight of the dry sand. So now we'll get the weight difference, that is what we called as mass or the weight, then divided by the volume. So this is equal to weight of the sand W1 minus weight of the dry sand W2 divided by the volume of the pipe or the volume of the solid content. So it will give the bulk density of particles. So this instrument you have to do multiple times, 4 to 5 times, then we'll take the average of a bulk density of a sand particle. And this is the standard method used to measure the density of the particle or the sand or soil.